Industrial Control Systems, or ICS, is a general term to describe the integration of hardware and software with network connectivity in order to support critical infrastructure. Our technology, ICS BlockOps, uses the blockchain technology to secure operational data in ICS. In a typical ICS, operational data from sensors and actuators is stored in the historian as records and for future analysis. However, there are several ways that the data can be used for malicious purposes. This can be via a cyber attack, unauthorized access by a disgruntled employee, a virus, or a malware, which can cause the ICS to malfunction. Our technology, ICS BlockOps, uses the blockchain technology and the advantages it offers to improve the security of operational data in 3 dimensions. Immutability, which means that the state of the input cannot be modified once it is created. Redundancy, in which the input can be restored even if it has been modified or destroyed. And lastly, privacy. A blockchain is a chain of blocks that contain information. Every time new information is added, a new block is created and added to the previous block in a chronological order. Blockchain stores information across a network of computers. Storing information this way distributes and decentralizes the information across millions of computers. Using a Bitcoin transaction as an example, the input into the block would be the sender, the receiver, and the amount of Bitcoins involved. The input, together with the hash of the previous block, is fed into a cryptographic hashing algorithm to generate a hash of the current block. A hash is a string of numbers and letters that is unique only to the input and its properties. Now, how do we ensure that the integrity of the block is not been tampered with? Imagine that there are 3 blocks P, Q, and R chained together. Block R contains the hash of its previous block Q. A change in the input in block Q, such as from a cyber attack, causes its hash to change. Because the input of Q has changed, its hash changes, and this is detected by block R. Consequently, all blocks after R are considered to be invalid. And because blockchain is a distributed ledger, everyone in the network has a copy of the blockchain. The computer that is under attack now has a different blockchain from others in the block. This computer is now considered invalid by other computers. ICS BlockOps is currently deployed in a realistic water testbed at SUTD. The testbed is used by researchers to develop defense mechanisms against cyber attacks on ICS. Data from each of the 6 PLC is stored in 6 corresponding storage nodes. The input from a PLC is also replicated in other storage nodes in the network. To ensure that the replication is trusted, this step is done in the blockchain. Each input also goes through a hashing algorithm to generate a hash. The hash is then stored in the blockchain network. The plant operator can also query the input from a storage node via a user-friendly query service for operational purposes. To ensure that the data he retrieves has not been tampered with, he validates it by generating a hash for the input and compares this hash with the one that is already stored in the blockchain. If they are the same, it means the data integrity remains intact. In the event that the input is altered or deleted, such as from a cyber attack or a hardware failure, ICS BlockOps redundancy function ensures that the data can be recovered. Let us take a closer look at the system monitor. The plant operator can view the register to see at which storage nodes the input has been replicated for redundancy. More importantly, the plant operator can view the real-time status of each of the 6 storage nodes and monitor whether the data has been tampered with. If the data has been tampered with, the affected storage node turns red. The plant operator can then zoom in to see exactly which input in the storage node has been affected. Here, the data from 11:12 a.m. to 11:13 a.m. has been tampered with. An option to restore the tampered data is available. Once restored, the storage node continues to monitor for any data changes. In an increasingly connected and data-driven world, our patent-pending technology, ICS BlockOps, offers an effective and extremely robust method of storing and protecting ICS operational data.